I appreciate the opportunity to give a little talk here. As Linux Girl mentioned, my background is, educational physics and the professional real-time programming. Uh, I cut my teeth on Fortran in the 70s, I guess, and or maybe no, or basic. Well, really Fortran, more than basic. Um, but I in no way have a CS degree, nor am I an expert at Python. So what I present to you today maybe if there's a ringer in the audience and they're a CS major, very knowledgeable about Python, identify yourself now, and so I can ask questions, or please be patient because, like I said, I won't provide particularly sophisticated CS insight. But I think you'll find this useful. Most of the cybersecurity people that use Python use it as a scripting language, or it's not their main the main part of their profession, right? The real work that they have to do is being knowledgeable about hacks and how to defend against them and how to hack a box or whatever. So Python is used as more of like an automation tool, but not necessarily in a way to develop reams and reams of code and all that. So this is talk is basically a, oh, here's how you can get yourself into trouble kind of talk, as in here's a weird thing that happens, and something to avoid and think about when you're coding. And so that's, and it's very specialized in that, but I think hopefully you'll find it useful. So the couple things to show you. First of all, this is a window into the Google Colab programming environment that you're looking at here. And let's see, I got to get my picture of myself out of the way. So just out of curiosity, if I hit full screen, let me know if this is more, is it still visible? Is it better?
It looks to be better. Yeah, it doesn't have the browser header stuff. So
Yeah, it does
Okay,
look
so there's
better.
more real estate here. Okay, good.
yeah,
Let's just go with that. So this is a Jupyter, so this is the Colab environment. And so basically you can run Python on a Google environment, Google computers, Google everything, right? And you can even, once you get your code working and everything, you can run it on a GPU, which, graphics processor. I think maybe even TPUs, because they like those. Those are tensor processor units. And your code can, in theory, run much faster, depending upon how you structure it and what libraries you call. So it's a really cool environment. The reason I love it is because the same reason everybody likes the cloud, right? I don't care what computer. I have like a half a dozen computers lying around the house, and I can pick up just a random one and go immediately to this page and start coding. And I don't have to worry about downloading a version of Python or Anaconda or God knows what to make it work, right? It just works because it's in the cloud and it's there. And it's accessible all over. I could go over to somebody's house and pull it up, and it's one thing. And I don't have to worry about downloading updates to environments or any of that. And I know that, I can throw my computer in the trash, and but it's still there. So and like I said, you can even use have access to high performance computing processors that Google will let you use to a limited extent, of course. And so it's a lot of fun. I don't know if any of you are familiar with Colab, but you can. I really like it. So this is in the form of a Jupyter notebook, and hopefully most of you are familiar with what that is. And I don't think it's specialized to Python. I think there are Jupyter notebooks for JavaScript and other coding languages and whatnot. So it's a nice blend of markdown language, right? Which is like a simplified version of HTML. And although you can include like equations and stuff, and then code. So like there are these cells. Here's a Python cell down here. Here's a markdown language cell, which has a lot of English in it and hyperlinks and so forth. So you can intersperse, or whatever the word is, blend uh, formatted English or whatever, formatted text with code, and you can tell a nice story that way. And so Python is an interpreted language. You run it basically cell by cell, at least in this environment. And so I'm going to read some of the stuff because I tried to make it. And again, all this material, I just put the link to it in the Python channel. By the way, why is the Python channel has a 0 for the O in the, does anybody know? That's not a question I know the answer to. It's an earnest question. So in our Slack environment, the Python channel has a 0 for the O in it.
Yeah.
Why? Is that like a pun or something?
I think when I created that, I don't know why I did that.
I thought it was a purpose.
No, I think it was either it was a couple different things. It was an idea of like a play on words. It was also leet speak where applicable, and I think it just looked better. I don't know.
Is it because the O and the 0 are right next to each other on the keyboard, at least on my keyboard?
No, it was intentional. It wasn't a typo.
Okay.
It was a typo. I would have fixed it. I did that, I think, on purpose. Just like hacking and a few of the other channel names are reminiscent of old leet speak. So. Oh,
leet speak. Okay, got
it.
Right. Yeah, I remember that. Right.
I was trying to be cool, but you just called me out. So apparently that wasn't the
it's
the end effect.
I know nothing about that.
No.
So it's in that channel. The link is to material. Don't just like log off right now and go look at it. But but you do have access to it there. So you can make a copy of this notebook. Excuse me. Copy it to your own Google Drive, fire up Colab, and play with this thing. So, and you won't hurt it because it'll be your own copy. Okay. So there's a lot of links to articles about this subject up here, and it deals with basically Python being a little bit weird. And what happens if any of you have used Fortran in the past or any, let's see, I'm sure this will happen in C, probably many other languages. But if you go outside, the first time when you were a youngster and you went outside your array bounds, right? You indexed in an array and you accidentally set the index to something outside of the memory of that array. You would miraculously see data changing that your code never touched, right? You have some array of, X and Y and Z positions, and you'd be changing them. And the next thing you know, your lat long positions all of a sudden change. And you say, well, how did that happen? I don't even have any code accessing them. And the answer is, well, it's because you went outside of the bounds of an array and you didn't have it checked and all that. So that feeling, so I learned that, 40 years ago. And so I was programming in Python a couple of years ago, and that happened to me again. And I had that feeling, wow, this is just like in Fortran when I went inside of an array bounds. And but there's no array here. I don't know what I'm doing. Why am I changing one thing and something else changes, right? And it caused my code to have a runtime error. So I thought so I figured it out and I read articles about it, and that's what this talks about. So we're going to step through it. So when you run a cell in a Jupyter Notebook, basically you can click in here, you can hit the play button, or you can hit Shift Enter, and then it's ran it, and then here's your output. So this first cell talks about something pretty simple. We're taking X equal to Y, 1, so just the value 1, and we're lazy. We want Y to also be equal to 1. So I set Y equal to X, right? Because I'm lazy. I could have set it to Y equals 1. And then I found out, and probably many of you know, that doing that does not create a brand new memory location for Y. It's by doing that, in essence, you're creating a synonym for the same memory location, the same data that X has. And the way you can check that is you can, in Python, you can take two data names or variables or objects, everything is an object in Python, and use the operator, the infix operator is. And this is not equals equals, right? Which is where they have the same value. This is R, Y, and X, the same thing, the same memory location, the same value, everything. And then sure enough, they are. And so Y is X is true, right? Doesn't create a new memory value. And you can look at their memory locations, and sure enough, they're both in location, whatever this is, a bunch of numbers ending in 96, right? So even though on the surface you think they're two different things, it's the same thing. They both point to the number 1, right? And that's the way Python works. So then you might say, okay, well, what if I change the value of Y to 2? How are they now related? Because a moment ago they were the same. They're identical, essentially. So if I do that, so that breaks the bond that Y and X have, which is what you'd expect. And they're no longer the same name. They're no longer the same object. And they point to two different numbers. And they're at two different places. One is a bunch of numbers ending in 96 and a bunch of numbers ending in 28. And the object in Y points to the latter, right? And in reality, in case some of you who are Python experts probably already know this, that if you look in those memory locations, those are reserved to be the numbers 1 and 2 respectively. Okay? You can actually go find that just the names, the string 1 as in the number, and the string 2, they're pointing to those locations. Can we couple them again? So suppose we said X is equal to 5 minus 3. So I guess I could take a poll, not a formal one, just to ask the audience. What will X and Y, again, be pointing to the same location? Because Y, as you remember, in the last cell was set to 2. And now I'm going to, take 5 minus 3. X is going to be 2. Are they going to have different memory locations? Which is kind of what I was, what I was used to when in Fortran or whatever. Or are they going to be coupled again and they're going to be pointing to the same location? So I don't know. Just answer in chat if you have the energy and see if. So Dante, can you look and see if anyone's answering the question in chat?
Yep. So we got some no's, then just some general, I think, thoughts. I mentioned location and what's in the location are different without trying to give away the answer. Paul also chimed in once a literal value is assigned, a memory location is allocated.
Okay, so let's find out. So how do we do this? Let's hit to be different, I'll hit the play button. And so they're identical again. Y is X is true. They're both the same deal, even though it's a little calculation here. I wouldn't know if I call it complicated, but the interpreter had to subtract 3 from 5, get 2, and so they're back to being the same number, and they're both pointing to this other location, the one ending in 28. Okay, so I guess that's not that astounding. The surprises will come later, but I guess some of the audience was surprised. Okay, so we got a preliminary conclusion here, is that the variable names are just aliases to data. When you think that you were changing the value of a variable, in a way you're not, you're just pointing to a different object. And maybe as a memory saving feature, an attempt to avoid garbage collection, hopefully everyone knows what that is, or some other arcane reason. In the example so far, objects are assumed identical if they're set to the same value. Okay, and by the way, just this Jupyter feature I mentioned, if you double click a text area, it'll open up a markdown language cell, and in here you can put some different abbreviations. It's kind of like HTML, but like I said, it's really like dumbed down. And although you can put LaTeX equations in there, was kind of cool. I haven't really played with it that much. Oh, and there's a helpful collab page that tells you how to do that. There's a handful of templates they have and other things that people share that says, well, here's all the cool things you can do with Markdown language. So. But again, just like that, here's the source. You hit Shift Return to run it, and that's the text there. Oh, and one other, I don't mean to get too sidetracked, but this is a really cool aspect of Python. You may want to, if you go for an interview and they ask you to write a bunch of Python and submit it, it's probably a good idea to run your code through a style checker. And there's a good one at this place, pep8online.com. So just for the whatever and giggles, I'm going to grab my code here and then run it through the style checker real quick just to see what happens, and hopefully nothing will break. There it is. Just paste your code here. There's my code. Check my code. And kind of messy. Continuation line over indented on line 6. Oh yeah, see, I've got this plus string. It's a little too far to the right, so it doesn't meet style requirements. I'm missing some white space around an operator. The style guide says you're supposed to, so right here, it's probably in line 6. I need a space there, that kind of thing, delete here. So it's kind of fun to do that, to see, maybe train yourself on how to properly, to write properly styled Python code. And like, everything that the internet has, it makes it really easy to do that. Okay, let's see, I think I have to hit the escape to figure out how to get out. Oh, yeah, maybe if I just do this. Nope. There. All right. How do I get back to my... If I hit the escape key, I should be going out of full screen. Okay, that Command W did it. So, all right. So sorry for being sidetracked. So that's what happened with the number. We've just played with the numbers 1 and 2. What about floats, right? Those were integers. Are we going to be in the same situation with floats? So here we are setting X and Y separately to the numbers 1.3. And then let's see if they're the same. So again, I'll ask the question. In this case, I'm setting them to 2 different numbers. I didn't set Y equal to X. I set X equal to 1.3 and Y equal to 1.3. So are they going to be pointing, are they identical? Are they going to be pointing to the same memory location, do you think? Or are they going to be different because they're floats? And again, let's have audience participation to see. So X and Y, are they identical or are they going to be different? Obviously, the values are the same. Question is, are they going to end up being identical names? And Dante, I'm going to ask you to...
let's see here. I'm going to just throw my hat in and say it'll be different, since it's 2 different variables being declared and one's not being set to the other one. That's my gut reaction.
Well, okay, let me tell you one thing though. Remember back here, X and Y were different, and then I set X equal to 5 minus 3, and they became the same again.
Yeah, it's Python shenanigans.
Yeah, so now hopefully I've completely ruined your confidence.
I'm so confused now. Seriously, now I'm just like going, wow.
Well, and just to, and for some context, and for others when they jump into Python, or if they'll research and look at, what are the key differences, because maybe some people are like, oh, what should I learn? What are the differences between like Python and or a compiled language versus non? And I think one of the bigger the thing this is what the freedom of Python, and yet the thing that will get you in trouble is because of the fact that with a compiled language, you are forced to allocate pretty much everything that's going to be pointed to somewhere in a memory location. Whereas with Python, you can get into a lot of trouble, as Dennis sort of been like alluding to, or at least give you some weird paradigms or some gotchas or caveats, to where you can get into trouble not realizing how flexible Python is, and how it assigns variables and how it assigns things to memory. So
and then he's talking about float, right? Yeah, it's like it's a float number, floating
Yeah,
number
it has a
now.
decimal.
So
Yeah.
By the way, I should have mentioned this before. In Python, there's no def. Well, there are defs just for functions and so forth, but I do not have to declare these names just by initializing them. Essentially,
yeah, I noticed that. Yeah.
I don't have to say X is an integer, X is a string, whatever.
Right. Yep.
It figures it out. It has
So
dynamic typing.
And that's the freedom of Python. I think why a lot of people love it, because there's not as many constraints as maybe other languages, but at the same time that can get you into a lot of trouble later on.
Yeah, how many of you have made a
expectations.
peanut butter sandwich with the sharpest knife in your drawer?
What?
Yeah, we're trying to spread cold butter on toast.
So X and Y, are they the same or are they different?
I'm going to say different, but I'm probably wrong.
And
I'm putting different because they're X and Y. So I don't know.
Because I'm under the philosophy of the variables, but again, Python always I put my foot in my mouth. But because a variable is takes up an allocation in memory, and technically, yes, the content of the variable is the same, but the variable is different. So that's why I'm leaning towards it shouldn't.
Yeah,
be.
I'm still
those
used
of you
to
that have read the print statements probably know the answer already. So let me just run it. Yeah, so floats, it doesn't work with, even though they're set to the same number, they're different, and the values are the same. So Y, has the same value as X. That's a true statement, but Y is X, they're not. Whereas if I had set them both to 1 or 2, then they would have been identical. So it works for integers, and actually small integers. You'll see that in a minute, I guess, but not for floats. Okay. So again, nothing really terribly dangerous here. Just because you have two variables pointing to the same spot, it hasn't been, the danger hasn't been demonstrated yet. It's just something a little bit surprising. And what about if you say after that, well, I'll just set Y equal to X. Now, remember, X is a float, 1.3. Y is a float, 1.3. All this does is just, I mean, the value of Y is still going to be 1.3. This is almost like a, this line of code, nothing's going to happen, you think, because X is 1.3, Y is 1.3. They're two different memory locations. If I set Y equal X, still going to be 1.3. And so we're just going to run it. And now they are equal. Y and X are the same thing. There's synonyms, as we suspect. And the Y now is pointing to the memory location that X has, no doubt. So, so let's take a closer look at all this. And so what these lines of code we're going to do, we're going to set Y equal to 1, or X equal to 1, Y equal to 1. And we're going to change, then we're going to change it to 1.2. So we're going to intersperse both integers and floats, and let's see what happens. So I'll just run the code. And sure enough, so when you set X equal to 1 and Y equal to 1, I didn't set Y equal to X, they both are set to 1. They're both pointing to, oh, by the way, I forgot to say this explicitly, the function ID of X. So that's, you may as well call it the memory location. It's probably something a little bit different, but we'll call it the memory location of X, right? So not only do they have the same value, but X and Y are pointing to the same memory location, even though I set them separately. I didn't set Y equal to X, right? Now I did the same thing for floats. X equals 1.2, Y equals 1.2. And sure enough, those are two different, as we might expect, those are pointing to two different memory locations. And so then I made this statement, and I talked about something that is really explained later in the talk, but it says, even though floats are immutable, setting two names to the same float gives the name different identities, and they're pretty far out in memory land compared to where the integers are, right? Here's the integer, what is it, 1? Yeah, 1. the integer 1 is at this location, something 96, and those two floats are way out there. And even though they're the same value, they point to two different locations. Okay, so this should be becoming familiar to you. I know it might feel like it's going a little slow, but it'll get kind of weirder later. Oh, by the way, I think I mentioned 5 minutes ago or 7 minutes ago or something, where I said this is a behavior of small integers. So let's take a look at that. So for x and y being 256, right? Are they going to be the same? But what about for 257? I think you can guess what the answer is. I'm not going to take a poll. So let's just run the code. And what do you know? So y and x, if you set it to 256, they are the same, right? But if you set x and y to 257, they're not. And so this behavior of setting a variable to an integer, and regardless of what variable you're setting to that same integer, they end up being the same name, only happens for the numbers -5 to 256. And why? I don't I have no idea. Why? What's so special about -5?
Yeah, that is very interesting.
Yeah, I mean, 256 is a power of 2.
Yeah.
So 256 is a significant number to me. -5 really never interests me as a number. I don't think. Not so. I have no idea, but I'm sure there's a reason. If you look at if you look under the hood of Python, I guarantee, and probably somebody somewhere knows exactly why. So, but anyway, this weirdness only happens from -5 to 256. Outside of that range, the integers end up behaving just like the floats do, and they point to different. Okay, so we got a conclusion that okay, so the conclusion should have been variable names are just aliases to data. It's a good way to think of them. They're actually objects. Everything in Python is an object. But the type and value of the data can change the behavior a bit. And the nuances are not just due to this mutable, immutable stuff, which you can go look up. I don't know if I want to explain at the moment. It's basically that, I'll try really, that some data structures are immutable, like integers, floats, strings, whatever. And what that means, you can still change the variable names and all that. It's just when you change the content inside, it can, like there's a tuple or tuple, however you say it, which is basically like, it's kind of like a list, but it's got parentheses instead of brackets. And once you set that, if you try to change the internal workings of it, you can't. Where a list, which is just a number of I want to say string, but a sequence of numbers, you can change the internals of that, and it's not a big deal. So that's a whole nother subject. I'm not going to touch that, but it does exist and it's relevant to this. So both float and integer are immutable, but assignments behave somewhat differently. Either way, dealing with a single number doesn't cause the fun surprise of data changing when you don't expect it. That happens with lists. Okay, so now we're going to get into the stuff where you can get into trouble with all this. Up until now, it's just been kind of interesting looking at the inner works, but nothing really terribly dangerous in this. Okay. So let's suppose so this is a list, X is a list, and it's just the two numbers 1 and 1, make life easy. And we're going to print it, and then we're going to set Y to X, and then we're going to play with it. So we're just going to run this code and see what happens. So X is this list, 1, 1. I print it, and then I set Y to X, and probably as you'd expect, they're equivalent, right? Y and X are the same entity, right? So in fact, they point to the same memory location, this mess, a bunch of numbers ending in 72. All right, and so okay, like before, everything makes sense. Hey, since these numbers are the same, I wonder if the elements are pointers to the same data, right? So the way you access a particular element in the list is you index it with these brackets. So like in Python, like all good computer people, starts counting at 0. So the 0 is the first element. And so x indexed by 0 is first element, x indexed by 1 is the second, and so on and so forth. So let's run this cell. And so what do you know? Not only are x and y the same, since they were both set to 1, right? Everybody's the same. We're all one big happy family. X0 is the same as x1. You got a true. Y0 is the same as y1. Oh, there's a typo. Excuse me. And I can fix it right now. Just put a little. I think I want to put x. I think I want to put a y here. And that's all true. And they're all pointing to the same memory location. The memory location of x0 is this number ending in 96. It's all, and if you remember, if you're good with numbers, you probably recognize that memory location. It's the same number 1 we had way up at the top of this Jupyter notebook. So everybody points to the same thing. And so I wonder if I change y1, what'll happen to the other y element, right? Since everybody looks like they're all pointing to the same memory location, if I start playing with the data here, is anything weird going to happen, right? So I set y1 equal to 0. So y1 again is the second element of this y list. Does anything weird happen? So let's run that. So, okay, they're no longer equal, right? Y0 and y1 are 2 different numbers, right? So they're 2 different values. They're 2 different memory locations. That's what this comparison does. That is, okay. So, so what do you think, without looking ahead, what's going on with x, right? And so all I've done so far, let's recap. All I've done so far is x0, x1, they're both the value of 1. They both point to the same memory location. And originally y0 and y1 were 2, but I changed y1, which is the second value of y. Do you think anything has happened to x? And this one I am going to ask for a poll. And I'm sure everybody knows the answer because I've been alluding to it during the whole talk. So I haven't touched x in the code, right? You look, I just set it originally to 1, and all I've done is now I've modified y. So again, Dante, if you could be so kind.
No, I think everyone's too afraid to fail the mental trick. Again, I think.
What was your question again, Dante? Are you saying x is still the same as y or what?
Yeah, so my question is, I set x, the list x, to be 1, 1, right? And then I didn't touch x after that. And then but I did modify y1. I set it to 0, right? And because y is now the numbers 1 and 0, right? So I haven't touched x again. Do you think anything magical has happened to x?
My gut reaction says no, but because of your talk, I would say yes.
Okay. Well, that's a pretty good way to go.
Yeah, deduction there. Yeah.
Yeah. So let's give it a shot. Well, what do you know? Y and x are still coupled, and they're both equal to the list 1, 0. So I didn't touch x, right? It was originally 1, 1. All I did was fiddle with y, and boom, x changed. Okay. So the first time I saw this, my reaction was rather visceral.
Why?
Right?
Why is it changing?
Yeah, well, I said that plus some really colorful adjectives.
It's Schrodinger's cat. That's what I'm blaming it on.
Yeah. I said, why something is it changing when I didn't change it, right? I said this to myself, so no, I didn't really, it was okay. But and I thought, and I immediately had that feeling in my stomach, like, oh wow, this is just like when I screwed up my Fortran program and went outside of an array and other stuff started to change. Or if you're familiar with pointers and you do something weird to a pointer, you know. So okay, so I refer to this as entanglement, because of my prior physics background. Well, actually, current, I teach it at the high school level or college, I guess, whatever, tutor it. So I refer to this entanglement, but that's unique. Don't go looking for Python variable entanglement. You're not going to find it. Well, actually, maybe you will. I don't think it's going to be this. So, because you change one, the other thing changes, right? And you didn't expect that. At least I didn't. So it has to do a little bit with mutability, this mutable thing. And unlike integers and floats, mutable data, the insides of it can be changed. And I guess sometimes even without you expecting it. Although if you're a Python expert, I'm sure you fully expected it. And so even though the elements were pointing at the same number, so for integers, they weren't entangled. I could change one, even though they were coupled, and the other one didn't change, and everything was wonderful. But with lists, because they're mutable, that's when things start getting nasty. And you change one list, when it's equivalent to another, the other guy will change too. So that was a bit of a surprise. So let's try to explore this further and see if there are any other weirdness here. So let's take x equaling 1, the list 1, 2, and we'll print it, and we'll set y to it, and we'll look at more and see what happens. So this is just, x is equal to 1, 2, and we set y equal to x, and now they're the same list effectively. They're coupled, and so now let's change both of y's elements. And so we're going to set y0 to 3 and y1 to 4. And I think you'll know the answer, what happens. Yeah, I've also changed x, right? So I set x equal to 1, 2. I set y equal, I'm sorry, I'm pointing at the wrong thing here. I assign y to the value of x or whatever, y equals x, however you want to read this. And it didn't set up a new memory location for y. It's the same as x. And so when I change y, guess what happened? X changed. So now x is 3, 4, and y is also 3, 4. So I didn't touch x, but it changed. So I guess that's not a surprise. Showed that in the last screen. So what happens if we, this one I am going to ask for a poll. What happens if I set y equal to 3, 4? So you'll say, well, you didn't do anything, right? I set x to 3. I'm sorry, I set x to whatever the numbers were, 0 and 1 or whatever. And when I reassigned y to 3, 4, x changed with it. So what if I just set y equal to 3, 4? What do you think will happen? Are y and x going to be the same? Or will this somehow change it? Because right now they're coupled, right? If I change one, it changes the other, even though I didn't intend to. Now I'm just going to take y and assign it to the same structure, the same numbers that it had. This is almost like a no-op instruction, if you know what that is, right? A continue statement. So are y and x going to be the same entities now? Anyone?
No one's chiming in. No.
I didn't do anything, right? I set y equal to the same darn thing that it was 5 seconds ago.
I mean, my reaction is that because they're using the same space, whatever either one does is going to change the other. So I think now x is 3, 4. That's just my guess, because y changed it to that. So
well, actually, they were both 3, 4. And all they did was reassign y to be 3, 4. It's almost like I did nothing to it, right? I just took y, which at the runtime was 3, 4. And I said, well, okay, why is 3, 4 again? It's like, you're Dante again. So
Yeah.
I mean, in this case, I didn't see any changes here. It looks the same. Like, I don't understand why there would be different.
Right. So it doesn't look like anything should change. Y and X should still be coupled. I didn't even change the values of Y at all. And so basically nothing should have happened at all. Right. So let's see what happens. It's true that Y and X are equivalent. They have the same value. But guess what? Just by taking Y and setting it to what it was. I think about it. I haven't tried Y equals Y. I don't want to do that.
Wait, you're just resetting it. You haven't done anything, Dennis.
I haven't done anything. Right? Well, I didn't think I did anything, but I did.
Yeah.
I decoupled them. They're still equal, but now they're equivalent. They have the same value, but now they're pointing to two different memory locations. And those are two different lists. So even though they're still both 3, 4, now they're different, right? And the only reason they're different is because I did a reassignment again, but I assigned it to the same value. You wouldn't think anything would have changed. Well, they did. Now they're pointing to two different places.
This is funny. The reassignment made a difference. Yeah.
Yeah. And so what happens? Okay, so now they're different, right? It says Y is X is false, right? So what if I now change the value of Y? What if I set Y0 equal to 1 and Y1 equal to 2? So now I am doing something, right? I'm changing Y, right? But notice how I'm doing it. This is rather subtle. I'm not changing all of Y. I'm changing it element by element. I'm changing Y0 to be 1 and Y1 to be 2.
Sure.
And I'm kind of cheating here.
Yeah, you're changing an element.
Yeah, so I did. So regardless, do you think X will change, right? Since Dante's a good sport, and he's answered every question.
I need to answer everything opposite of what I think is the
the George Costanza theory.
Yeah.
Right?
Remember that episode?
The answer is going to be different, right? They're just going to be different.
No, well, see, he ends the line 6, but they're fully decoupled, meaning that then you would think then they would be different, but now maybe they're going to be this again, opposite world, up is down.
Okay.
It's opposite day, right? So they were the same values, 3, 4, 3, 4, but in the last cell they were actually two different memory locations. That should tell you the answer. So now I've changed Y. Do you think X will change?
If they're fully decoupled, then they shouldn't.
Right. Good. I was giving you a big hint in the. I don't know if you're looking at my face.
Oh, if there were fully decoupled.
Well, that's what I was looking at. I was looking at line 6. It's hinting to they're fully as a reminder.
No cheating. No cheating. So, all right. So, and yep, they are different. So I changed Y. X didn't change. Okay. So the weird part, at least to me, is that, well, now, I didn't do anything a few cells ago. All I did was take, when Y was 3, 4, I set it to 3, 4 again. By doing that, it moved it. So now the two different memory locations, completely decoupled, and they're separate entities, right? So that's kind of fun, I suppose, for some people. Hopefully all this will be explained later. Because right now I'm sort of just hitting you with confusing little anecdotal instances, right? But the theory behind it, sort of the grand unified theory behind it will be presented shortly. All right, so let's try it again with small integers, right? Let's just recap. We got X is equal to 1, Y is equal to 1. And are they the same? And then X is equal to 1.2, Y is equal to 1.2. Are they the same? So you should be able to answer this.
Yeah,
And
so
by the
that-
way, notice the dynamic typing. I have changed X and Y. They're back to being integers now. They were lists a minute ago, right? They're like these one-dimensional, these vectors, I guess you can call them. Now they're back to being numbers. So when I compare X and Y, are they going to be the same with the ones? And are they going to be the same with the 1.2? And hopefully you know the answer.
So I would say in a normal universe, the ones, the first set should be equal. The second set should be different because
Right, because
that's what
floating.
at least happened in the past. But
that's right, integers. So you retained that nuance knowledge.
Right. So
Okay.
the integer will be different than floating, folks.
Yes.
So we get that, right? You demonstrate that in the previous
Right.
example.
So hopefully nothing weird is going to happen. And that's
Yeah.
what we're gonna see. And hey, it worked. So it's exactly what you said. So you guys are getting this. Y and X are the same when they're both one, set to one, and Y and X are different, right? False, right? When they're set to the same number if it's a float. Okay, so you got it, right? So that's good. You remembered that from the beginning of the talk. What about lists? I got a list where I set X equal to 1, comma 1, right? And Y equal to 1, comma 1. Are they going to be the same?
Okay, so this is a list.
yeah, this should be the same.
Should be the same.
It should be the same.
All right. By the way, is there code hanging? All right, let's find out.
Yeah.
What?
Wait, I don't remember now. Now, I remember it got changed because you did the reassignment. So what? Why is this? I'm confused. Why is this different now?
Well, so first of all, you should feel comfortable
Yeah.
that you're confused.
Oh, thanks, Dennis. Now I'm
This is
kind of like,
confusing,
I
right?
remember when you did a reassignment, things got changed. So that was clear, right? You assigned the same
Right.
thing. Yeah, but this one, I don't remember now. I mean,
So let me peek ahead to see how far, because I'm going to give you the punchline. I think that we do it later. So let's just leave it. So when I used a list, right, and I set X equal to 1, 1 and Y equal to 1, 1, you expected them to be the same, and they're not, right? And why that is or what's going on, I want you to hold that question for a little bit, because there's going to be another surprise in a couple minutes that, so I'm glad you both answered incorrectly, because that means that you're surprised, and that's the whole point of this talk, is to have surprises. So they're not the same, right? When they're lists, they're not the same. When they were both the number one, they're the same, but when they're lists, again, all pointing to the same 1, 1, they're not the same. And in case you don't remember, I'll just tell you, about 8 cells above, I didn't set them to two lists independently. I set X equal to 1, 1 and Y equal to X. So before, like I said, cells above,
got it. That's how
were
you
the
said
same.
it. Mm,
But this time I set them independently to 2
independently.
literal lists. Now they're different.
Okay, got it.
So they're different, right?
So lists and floats now are on the wanted list.
Yeah. So they're different, right? Or are they the same? Or is that problem still there hiding, right? Are we really sure that they're different, even though they look to be different, right? It says Y is X is false, right? They are different.
Right.
Or are they the same? I guess we're going to find out, right? Later, maybe. So to recap, I'm sorry, I'm going to read this literally. But so what have we learned so far? Trying to make a copy variable by assigning a name to the original variable doesn't really make a new copy. It just points the new variable to the same original value. assigning a name to a small integer completely couples it to the integer, so much so that assigning a new name to the same integer gives it the same assignment as the original, right? I think you understand that.
Yeah.
All right, so reassigning any of the names to a different number breaks any coupling. So this is like a recap of what went on with the integers and all.
Yeah.
Just nothing about lists here. Floats and large integers pretty much have the same result as small integers, but the coupling is not so strong. So they're loosely entangled or something. Reassigning a name to the same value as it had before uncouples it, which is true in all cases. Lists are mutable and names are tied to a specific list. Setting a new list to an old name couples it to that name, so much so that changing the values of one list automatically changes the values of the coupled. So that was the first big surprise, that these lists, unlike the integers, actually get coupled. So unlike integers, setting a list name to a list literal that looks identical to its current value decouples it and gives it a new identity. So that last sentence refers to the most recent cell, where things were kind of surprising that it looks, even though they're set to the same very simple looking list, they're not the same guy, which is different than what happened with small integers, right? So is there a way to copy a list and assure that the copy points to a new list, right? So is there some way around this? Is there some safe way? Because this equal sign is now, boy, it's getting windy out. This equal sign is starting to be dangerous, right? It's
Yeah, you can't trust it.
Yeah, I don't trust the equal sign.
You don't trust it, yeah.
Yeah, I thought I knew what an equal sign does. Now I'm beginning to wonder. Right?
So I see a dot copy thing on the bottom.
Right. So there's a method called the dot copy method. So let's try that and see if it works. I'm going to run this cell. I set x equal to 1, 2, and I set y, y equal to x. And as you can imagine, they end up being the same thing, right? And if I change one, I change the other, right? So let's try the dot copy method. So in the dot copy method, you put y, instead of saying y equals x, you say y equals x dot copy. Okay, so it takes a copy of x, puts it in y, and are they the same? Y is equal to x, false. What are their memory locations? Different. So the dot copy method created a new list equivalent to x, and now y points to this new list. So I think, problem solved, right? The dot copy method will save me from accidentally, making a copy of a list. And the way this originally happened, by the way, just to give you the background, I had this fairly complex data structure. It was like I guess it was a list, maybe it was an array. I don't know. I guess it must have been a list. And it was like, one dimension here, 2 dimension there, a string, whatever. And then I wanted to create a new list that had the same structure, but I didn't want to fiddle. I wanted to do it in the cheapest, quickest, dirtiest way I could. So I thought, I'll just take this new list, set it to the old one, and then I can modify. I don't have to go through all the machinations of setting this complicated list up, because it just grabs the other guy and makes a mirror image of it. Little did I know, though, once I started changing the second one, the first one changed. So I thought, okay, so in creating this Jupyter notebook to try to explore this, I discovered the dot copy method. It looks like they're pointing to 2 different locations, right? Problem solved. Nothing bad's going to happen, right? So Dante, I'm going to ask you, problem solved.
No.
Yeah. No, you don't want to answer? No.
It's both answers. It's the answer to your answer and your question. I think that
bad things
technically I would think that it should. If the X copy does what you would think it does and creates a copy of the list in a different memory space, then whatever you do to that other one should, I would think, would not affect the other.
And look, there are even 2 different memory locations, right?
Yeah.
Right.
So how could they be a problem?
But the way you're phrasing this leads me to believe there's going to be a problem.
Yeah, I mean, to me, it shouldn't be a problem. They're pointing at different places, right?
So maybe George Costanza, we should invoke. Maybe we'll see. All right. So what if we change one of the elements, right? What happens, right?
That shouldn't affect the other one.
And so I set y0 equal to 3. And you're right, they are decoupled. So even though you had trepidations that there was going to be a problem, there's not. They're completely decoupled. And
all is well in the world again.
All is well in the world. So it looks like the dot copy is going to save us, right? So
yeah.
So here's the conclusion. Here's the conclusion. So, okay, if you want to make a copy of a list and assure that modifying the new variable won't change the old one, use dot copy, right? Use dot copy method, but I'm wary now, like Pete Townsend, right? Hopefully everyone gets that illusion, the joke. You get that, Dante?
From the Who?
Yeah.
Yeah.
So the song, I was going to say like Pete Townsend or George W. Bush, because he actually scoops it. So that's the won't get fooled again, right? That's what I'm alluding to here. But what happens with a compound object, like a list of lists or a 2D matrix? Okay, you think dot copy is still going to be your friend? What do you think? What if and here's a 2D matrix, by the way, see it? It's
I'm going to say, yeah, I'm going to say dot copy should still be our friend in solving the issue of making sure they're in two different spaces.
Okay, good. So you're an optimist. You're
yeah.
not doom and gloom. Good things happen to good people, right? Isn't that an expression?
Yeah.
No, I think the expression is bad things happen to good people. As in, why do bad things happen? But let's find out. Maybe you're right. Maybe this is not foreboding. So, I don't know. Linux girl, what do you think? You an optimist like Dante? Linux girl? Oh, we can't hear you. Either you're muted or you're afraid to answer, which is maybe the right decision. So let's run it and see what happens. All right, so X is this complex, this like a matrix, right? It's a 2 by 2, and it's the first row, or the 0th row, is 1, 2. The first row, as in the second row, is 3, 4. I do an X dot copy, and are they the same? X is Y is X, right? And they're not. They're not the same. Look, one points to 44, something. Well, a very large number, memory location. They're both different. So it's okay, cool. X and Y are different, but I'm still afraid. I'm still afraid. Let's try changing one element. So I'm changing the element 0, 0. So Y 0, 0, right? So that's like, think of a matrix, right? So that's like the second row, the first element of the second row, right? So before it counted 1, 2, 3, 4. Now Y is going to be 1, 2, I think 0, 4. No, I'm sorry, 1, 2, 5, 4. Right? That's what Y should look like. And the question is, okay, will X be changed? Well, of course, the optimist would say no, because X and Y are pointing to two different memory locations. Why in the world would they change? Right.
Yeah,
that's right. They shouldn't be changing.
They've been decoupled. We're modifying the copy that's in a different namespace. So
and our good old friend who will never ever abandon us, dot copy, is like our old significant other. Would never do you dirty, right? Would never do anything bad to you. So good old dot copy, I'm sure will come through. And what happened? Oops.
What?
So X did change. X is now 5.2. Oh, and by the way, I said like it was the bottom left. It's really the top left. It's like the very first one. X and Y are the same values, even though I didn't touch X, right? I just touched Y. And they're in different memory locations, right? Or so we think. So why and how in the world did X change? Right? And this was, again, we used dot copy. We thought we were safe, but they're entangled. So let's look at the elements. So Y0 and Y00, X00, they're the same. They're the same. They're the same. They're the same. They're all the same location. How did that happen? Because I know that X and Y are in different memory locations. Remember way up here?
Yeah.
Memory location of X is this number. The memory location of Y is this number, right?
Yeah.
Those are two different memory locations.
So,
Why are the individual
mhm.
elements of the matrices identical? They're all in the
Hmm.
same memory location. Well, I'm sorry, analogous. So Y00, X00, they're the same. Y01, X01, they point to a different place from the 00, but they still point to the same place. So the elements, the internal structure of the matrix is entangled again, even though we used our good friend .copy. So now we're getting upset. So X and Y are different, but their elements are entangled. Egad, that was not what I said the first time I saw this, but I thought that would be a nice family-friendly version of this. So not only does .copy not do what I thought it did, but my Y is X test is misleading, right? We had a red herring or whatever the expression is. I thought Y was different than X and it wasn't. So the internals of Y and X got entangled, even though the overall memory location was different, right? So so let's look at that. So I'm going to print the memory locations. So again, X and Y are two different places. Okay, so the two matrices are in different locations, right? He said nervously. What about their elements? Well, their elements are pointing to the same places. All right, so X00 is pointing at this location, which is the same thing as this one, 109, 14, 624. And if you remember, if you have a really good memory of numbers, these numbers are good friends, are the literals, I don't know, either 0 and 1 or 1 and 2. I think they're 1 and 2, right? So the internals point, we're getting that nasty entanglement, and it's worse this time because now when we change one, we change the other. It's worse this time than it was with integers, okay? So let me pause for a moment and ask if there's anyone that's lost or has any particular insightful question. Because I know this gets confusing because I keep talking about things being coupled and uncoupled and coupled. And I tried to go through a pace where everyone could follow. And right now, the bottom line is our good friend .copy was really not our good friend. And even our good friend, the is infix operator, is also not our good friend anymore because that misled us to think everything was cool and copacetic, which is not a real word, but and it wasn't. So does anyone have any question about what's going on?
So Dennis, Brian says he's still wrapping around his head around everything, just to let you know.
Yeah, and I apologize for if this is confusing. If I was in your shoes, this would be very confusing. In fact, I've gone through this concept, I don't know, 3 separate times, 3 different weekends, months apart. And I have to I have to
like
reorient myself.
they're the same, but they're different. It's like the question, you know, with physics, it's like is a photon a wave or a particle? It's like you look at it one way, especially with the copy making the ID. Well, that we see the X and the Y being different namespaces, but then the element versus as a whole, and then those are in the same spaces. So
Yeah, see, if you look at the example right now, the element, they're the same. So you're showing the example, right? The
Yes,
element,
the sort of the
Mhm.
well the for X and Y, which are now lists. I'm starting to get lost now, but the X and Y are lists. The overall memory location of X and Y, the IDs,
the
right,
IDs are different.
are different. But then if you look at the internals,
Yeah.
So by the way, the same but different. I'm going to date myself, and if I had a T-shirt, you know, I would throw it out to the audience whoever got this right. But all the same but different. What's that reminiscent of? In like 50 years ago, 50? Yeah, 50 years ago. How many of you are know what the heck I'm talking about? It's all the same but different. See if anyone. I'm gonna look in chat. I don't know how to look in chat. I have to go up here. Yeah,
I mean, there's got to be. I am sure that there's a reason for all of the insanity of like, you know, maybe or maybe not. I don't know. Maybe this is totally just a fault.
Oh, by the way, my question is a non sequitur because Dante, you said all the same but different, and it just rang a bell.
Huh? Oh. Well, I don't get most of jokes.
So is there anything
I don't
in
get.
chat? I can't see. I'm sorry. I apologize, but I can't. For some reason, I can't see chat right now. I don't know what to click on because I'm in full screen. So does anyone know the answer to all the same?
No, it doesn't. It just some comments. It appears the list element itself is the couple,
Okay,
but the element data within each is entangled, which is kind of what I was referring to.
Let me restate the phrase. So what about the phrase twisty little maze, all the same but different?
Over my head.
Well, I think I'm dating myself. So no one has played Colossal Cave or Adventure or
no one's chiming in now.
Never played Colossal Cave or Adventure. Oh my God.
Paul says he was 12.
Paul, all right, I guess, yeah, that's a little young. Well, the first time I played Adventure was in 78. No, 79. And it was almost like at that point it was probably at least 5 or 6 years old. So it was one of the original well, it's not a role-playing game. It's a puzzle game. It was on probably written on a deck.
It's like a choose your own path sort of thing, or
yeah. I can't believe any. All right, so look it up. That'll be homework. Look up Adventure or Colossal Cave because I'm sure they have online versions. And
yeah, I think the first game I remember besides Atari was like Oregon Trail or something. Besides like Pitfall or.
Yeah. So yes. So subtract a good 15 years off that.
Right. Yeah.
Yeah. So this was text based, and you basically you were presented with a scene, and you could ask questions or do something, and the computer would respond, and you could move around north, south, east, west, and you discover things. So, all right. I feel so old. Okay. So dot copy stinks, right? It's no longer our friend. So what's going on here? So this, I don't know if I want to have time to go through it. Oh gosh, I've already eaten up an hour. Well, probably an hour and a half. This tutor, the pythontutor.com link, this thing's wonderful, and it works for C, C++, Java, JavaScript, Ruby, and Python. And what you can do in here with this tool, and I'm not going to run it now because I don't want to run out of time, is you plug your code in here, and then you can step through your code, and at each step of your code, it'll show what's going on. It'll move, when you define a variable, it'll show where it is in memory. When you change the value, it draws little arrows of the data flow, and it shows memory moving around and equivalence setting up and all that. And this thing's like really, really cool. And the link is in the Jupyter Notebook. Please go use this. If you take one thing away from this talk, other than confusion, learn how to use this thing, because this is so much fun, and it will tell you how to. We'll tell you how memory gets set up in the language, which is different for each language, and you can take snapshots and screenshots and impress your friends and all that. So, and how did I get out of here before? I think I hit Command Tab.
Something W.
Yeah, thank you. You are paying attention.
Sure.
Command W. You are paying more attention than I am. So thank you. Yes, Command W closes the window. So please play with that, and it shows you visually what is happening. And I guess this will be much less confusing if you ran that. I mean, I should have made the talk based about this thing, right? But so take the time to exercise that tool. If nothing else, go run that thing, okay? So what's going on here? Why did .copy fail us like a, an ex-spouse? So the variables X and Y are definitely different, but their elements are entangled. And the way around this is to use something called deep copy. So we're not going to use copy anymore. We're going to use the method copy, or the function. I guess it's the function. I think copy.deep copy. Was .copy a method before? Now it's got me wondering. Yeah.
Or is it the other way around?
Yeah, but this is a function.
Yeah. Function of the method or something.
Yeah. So this takes X and it makes a deep copy of it. So let's try it. So do you think, before I run this thing, what do you think it'll work? Will deep copy be our new friend? We've dumped our prior friend.
Yeah, this should be our savior, I think.
Yeah, I mean, you're giving us a hint, right? This one is the last thing on your sheet. So I assume deep copy is better, right? It's
and
our
you're right.
friend.
Yes. Just like your second spouse. It worked. It's great. So what happened? So we set X equal to 1, 2, 3, 4. We made a deep copy of it, and we changed the first element again, 5. So X and Y are both 1, 2, 3, 4. Changed Y, and voila. X is pristine, did not change. Deep copy is our new friend. And I printed the memory locations of the individual items, and you can see that, yeah, the other 3 might be pointing to the same location, but let me see if I can word this the right way. So even though it looks like everybody was coupled, they weren't. That when I changed Y0, Y00, 0, I changed it to 5, the interpreter somehow knew, hey, even though a moment ago they were pointing to the same memory location, they're not happy, right? Because when I change one, he gets pulled off and points someplace else. So they're no longer, so even though they're pointing the same memory location, they were decoupled. So just because, in fact, I didn't do it here, but I should have probably checked the is on all the elements to see if they're the same, and they're not, right? So good, so decopy worked. We like decopy now, right? So great, looks like decopy worked. It'll protect my original matrix when I change a copy, a brand new copy is made when I use deep copy, and if I change it, the original matrix is protected. So after spending a full weekend, actually, I guess a couple of weekends, if I count this weekend, trying to understand the nuances and ramifications of something as innocent as a Python assignment statement, I find my use of the exclamation great in a non-ironic way a bit shocking. And at this point, I assert that maybe I'm suffering from the sunk cost effect or the Stockholm syndrome, if you know what that is. right? Wrongly characterized as Helsinki syndrome in Die Hard. So does everyone know what the Stockholm syndrome is?
I'm familiar. Well, I'm familiar with the idea of it. Yeah.
Yeah. So basically, if you're held hostage, you start to like the people holding you hostage. So at this point, I've been held hostage by Python's assignment statements, and but then now I've got deep copy here, and I'm appreciating deep copy, but maybe I should still be resentful that I have to deal with that, right? So that's interesting. So let's look at one last thing, since it is getting late in the afternoon. Hopefully you found this somewhat interesting. So how do we initialize a matrix safely? If you remember, I said the way I originally found this weird stuff is I was lazy, and I had one matrix which I initialized, or I had in existence, and then I wanted to create a new matrix that was similar in structure to it, and being lazy or efficient, or whatever you want to call it, I just set the new matrix equal to the old one, thinking that, okay, now I can change it, it won't harm the original. And next thing you know, bad things were happening, right? So how do you initialize a matrix safely? So let's say we have a matrix X, which is a 4x5, right? So it's 4 rows, I guess. So five columns, right, of the number 1, and 4 rows of those 5 ones, right? So here's a sort of lazy person's way of initializing it. And this times is not multiplication, right? I want the times, essentially, this operator, I'm sorry, the asterisk operator in this context is really like duplication. It's not multiplication, right? Hopefully, in whatever language is your preference, you understand that when you see an asterisk, it could be either multiply or it could be duplication, depending upon the context. Does that make sense? I'll assume everyone's saying yes, that makes sense. So, so I'm going to print X, and let's see what it looks like. Okay, so this sort of lazy person's way of initializing X to be a bunch of ones worked, right? I've got 4 rows, 5 columns, a bunch of ones. It looks okay, right? But is it? What do you think will happen?
Don't.
It looks
Dante.
okay.
No one else but Dante is required to answer this question.
No, but I say it looks good.
Yeah, thank you. It is pretty, isn't it?
No, I mean, that's not what I meant. I mean,
Oh,
it looks
harmless.
it looks, yeah, it doesn't look it's harmful at this
So let's
point.
recap. I don't have a Y. There's no Y in this example.
Yeah, you don't have a Y. That's true.
I got X. It's just a matrix, a 4x5.
Yeah.
It's a bunch of ones, right?
Right.
So it's this nice, it's not the identity matrix that would be diagonal ones. It's just a bunch of ones, right? So it looks harmless. I'm going to change. I'm trying to hide the answer. I'm going to change the upper left 1 to the number 0. Okay. Let's take a peek if I can. All right. So so what do you see at the very bottom of your screen? It should say x00 equals 0, right?
Yeah. Yep. You're changing the X values.
All right. And I'm hiding everything else. All right. So I need an answer. I'm sorry, you have to answer this. What will the matrix look like after that one line? Okay. I'm not going to even make a multiple choice. I want fill in the blank answer. What will the matrix X look like once I execute that line of code? Right now it's a bunch of ones, 4x5.
Yeah.
And
Yeah, I
that's
can't see the last line for some reason. I'm in a Zoom, or maybe I had to do. Did you?
I
put
see the
0?
X00 equals 0
Oh, X
in brackets.
Okay.
Yeah, X left bracket 0, right bracket, left bracket 0, right bracket equals 0. All right. What will the matrix look like after that one line of code? Is anyone brave enough to answer? I'm sure someone is.
Maybe just a 0, 1, 4, or 4 zeros.
Okay, so how many rows will
like one row of 4 zeros, maybe.
One row.
That's 1 0, right? 1 row, and how many is it? 4 zeros. Yeah, because you have 4.
By the way, let me help you with the syntax.
Oh, one column of 4 zeros, maybe.
Right. So let me help you with the syntax. X00 refers to only that upper left element, right? The very top left element.
Yeah, that's
all
true.
I'm doing in the code is setting that very first one to the number 0.
Okay, so the first one will be 0. The rest will be 1.
Yes, I think everyone's agreed. The very first one that you see in the upper left column is going to be 0. What happens to all the other ones? Will they change? Will they be the same?
They will be the same as 1. They wouldn't be changed.
I would think they should be the same.
Yeah.
Okay. Are you two in agreement?
That's my final answer.
So the first one, so then it's the first one would be 0, right? Because
the very upper
first
left,
right, will be 0. The remainder will be 1. It's still the same. Nothing got changed.
All right, everybody. So what you're saying is the matrix will look like a 0 in the upper left.
Yeah.
Everybody else is a 1.
Correct.
Okay. And Dante, you agree?
Unfortunately, yes. I'm going to be
Come
fine. I'm going to put my foot in my mouth. But yeah,
that sounds logical here, right?
All right. So do you want to? What's that show? Do you want to call a lifeline?
Right, and phone a friend or something.
Yeah. Do you need a lifeline?
Who are you going to call, Dante?
I
You
know.
can't call me. You can't call me.
Yeah, no.
So sorry. Anyone in the audience want to be a lifeline?
So are you saying we're wrong?
I didn't say that. I'm not supposed to say that because otherwise.
He's using reverse psychology that we psych ourselves out and we think that we're.
Yeah, reverse psychology with the Helsinki syndrome and the Stockholm and the social engineering and.
Yeah. So Paul, what did you try? He cheated, and what? What do you say?
It's easy to cheat because I already told everyone the answers are in Slack. They could be running this in parallel on their computer, and so that you can cheat. But we wouldn't cheat. Would a hacker ever cheat? No. A cybersecurity hacker?
Yeah, right. Yeah. Wow. The first one. Oh my God.
Oh, I figured out how to. Now I can see. What do you call it? Chat. I can actually see chat. I'm afraid to look in. Oh, there's 40. Will do. Ron, I recommend you look at. Oh, that's the very end.
Yeah.
Sub-elements are coupled. I cheat. Oh, someone did cheat. I already tried it via Python. Is that how you say it? Python? Or Python?
Oh, typo.
Oh. So, that's okay. Cheating is not so bad.
Sorry, I had a typo in there and I just gave up trying to fix it.
I thought Python was a cool, you talk into your phone in Python and the answer spits out.
Dennis, I'm old school like you. Okay, I'm literal. Come on now. It was a typo.
So let's run it. Okay. Let's try to run it. And just like Paul said, that was Paul, right?
Yeah, that was.
Yeah, it was me. It was me.
So it's no longer egad. I got arg.
See, I had a feeling the first column would have been zeros, but I was thinking it would have only been one column, and I thought maybe the ones would have disappeared magically or something. But
yeah, you said that. How what made you say that? Because you said, like, in the very beginning, you said that would.
Because I felt like that was, I don't know, just the way the presentation has gone. All the obvious is no longer obvious anymore. So
that was like a gut feeling.
The one time I got was right for the change.
But to me, that it's pointing to that left one. So I look at that. I don't think it's going to affecting other rows.
I would have thought that too.
Why? Because I'm so drilled down to each specific element versus this thing. So, oh darn. Sorry, somebody is texting. Yeah. So Yeah. So that's interesting.
So how I initialize, so what happened was the way I initialized the list provided an unintended entanglement. X0, X1 is true. X1, okay, X0, X1. Oh, it's saying the rows are entangled, right? Let me help you with that, the syntax. So when I say X0, notice I'm not using two indices, I'm using one index. So that means the X0 is the first row, the row vector here. That's what X0 is. And X1 would be the second row. So those are the same. So that's why all the rows are entangled, their first element. And the reason they are is because of remember I said I was going to be lazy here and clever, the way I initialized my matrix? Maybe this is actually a knock on Python, because just by this assignment statement, it's actually setting things up in memory in a way that maybe you didn't expect, because you're not using a real declaration or something like that. It sees this mathematical phrase and interprets it to set it up so that all the rows are coupled. Okay, and so that was nasty. So suppose we initialize it differently. Suppose we say X is equal to, now this is the same structure, right? It's a 4x5 matrix, right? But we're going to set it up to be like this. So 5 star 1, 5 star 1, 5 star 1, 5 star 1. So instead of using the duplication asterisk twice, we're just using it once. And so I got 5 ones. So a row of 5 ones, a row of 5 ones, a row of 5 ones, and a row of 5 ones. Do you think that'll address our problem? Do you think that will, so we're less lazy?
I think this will fix it.
Okay, so Dante confidently says it'll fix it.
I don't know. I have to see.
Okay,
I mean,
so you're like,
I can't.
You're the
I
proof.
can't trust anything now.
So not only don't you trust anything, you don't trust Dante's judgment.
That's right.
That's a wise decision.
I mean, a lot of times you make assumption on certain thing, you just fail, right? So the only thing is try it, hack it, and then run it. Like,
Yeah,
see the answer, right?
Yeah, that's safe, and I think that's a good idea. But looks like Dante was right. That did save us by declaring each row separately.
Yeah.
But when you define it, how do you explain? When you define this a better way, it prevents you getting unexpected errors, right?
Yeah. So by initializing the matrix in this manner,
right,
it's safer. The rows are decoupled. Weird stuff didn't happen when I changed the upper left-hand value. Only that guy changed. Everybody else is a 1, which is kind of, I'm sure that's what we wanted, right? Nobody wants to. I guess if you're really clever, you might want to do it the other way, but I don't think so. So good. Each row is a different list, and X0. So the 0th row is different from the top row. I'm sorry. The 0th row is different from the 2nd row. So initialization, you got to be careful, right? Even though we're not even talking about Y, we're just talking about X. But each row, you can kind of think of them as separate X's and Y's, I guess. All right. So is there a better way to, so this is kind of clumsy. It worked, it's safe. Is there a sort of a cooler looking way to initialize?
A more efficient way other than
your first more efficient way. Or nicer looking, whatever.
I would say less mistakes. When you initialize something, make it clear so that you will get expected results.
Yeah, that's a really good state. What you just said is making things clear. So a lot of people, a lot of coders are they're hackers, and they love doing things, in the fewest number of lines possible, in a way that's is esoteric, but it looks sexy. And I am definitely not one of those people. I'm definitely an advocate of the number one thing is make your code clear. Number 1.1 is make it run fast, because I do have real time. But I guess in some cases, if you have to have it run fast, it's hard sometimes to make the code perfectly clear. But
I mean, seriously, a year later, can you still understand your own code if you have to debug it, right? Make it less.
Yes, very important.
Make it less. I have personally had experience writing really, bad code, and then a year later I had to debug my own code that was like, what did I do here? I just don't remember. So
this one uses the dot append method. Is it a function or a method? What is that method? And so you initialize X as just like an empty list, right? And then you have a one-line for loop, which says, so it loops through the numbers 0 through 3 or whatever. And it takes X and appends to it a row of 5 ones. And the reason it came up with hover, never mind, it's a distraction. I'm just going to run it. And so it did. It created 5 ones. It uses this dot append method. And let's reassign the upper left to 0, and it's still safe. So the dot append method is pretty cool. So that works too. I guess that's more compact than the other way. I'm comparing here this code, right, with this code. It's a little more elegant. I don't know. Although maybe this takes longer to execute. Probably does, right? Because this.
Yeah, I mean, I'm talking milliseconds, but yeah.
Yeah, or even less. But it's okay. It runs pretty quickly.
I would think the loop would take a little longer to execute, but it gives you the ability to put a variable in for your range. So if you wanted to use it in a function and say declare out this array with 5 elements versus 4 versus variable number of entries, you could do so.
Yeah, that's very insightful.
And then, I have to say, sometimes is it really the performance? I mean, does it have to be fast, or does it? Well, it depends on the situation, right? If
depends on the situation, yes.
Yeah, mission critical thing that has to be.
By the way, it's funny because I was thinking of another talk.
Yeah.
I was doing coding exercises, like these little puzzles that they give you for interviews. And there's a famous puzzle called the zombie apocalypse puzzle. And you had to create a matrix of zombies and then do the equivalent of some sort of binary search or something on the matrix. Because every time, it's iterated, and every time a zombie touches you, you become a zombie and all that. So then, so I ran it, and I just did a really stupid version of the solution. It got the right solution, but the evaluator on the online evaluator said, your code took too long, you lose. So then I had to rewrite it, and I remembered, oh yeah, I can, it was in Python. So yeah, I can use pointers to move arrays around rather than actually moving an array. And then it came in at like 100th the amount of time, but it was still too damn slow, and at that point I gave up. So I was thinking, well, maybe I should give a talk about some things you can do to make your code run a lot faster. Like using pointers for arrays that you're moving around and that kind of thing. So that's a potential future talk. So that one worked. It worked great. And like Paul, I guess, or whoever said that, you could pass a variable for the dimensions of it. So hey, we're at the end of the talk. Cool. So what did we learn? Well, let's see if we can summarize this. I kind of wonder what other nuances happen with entanglement with sets and dictionaries. So sets and dictionaries are 2 other types of data structures. We just looked at like integers, floats, and lists today. But sets and dictionaries are also mutable. And I kind of wonder if you did the same little exercise here with sets and dictionaries, would you also get the same surprises, right? And I assume so, because they're all mutable, but I don't know. I haven't played with it yet because I don't I found other stuff to do with my life. But that would be interesting.
Wow.
So what did we learn? Variable names are really pointers to data. It's not like as much as a memory location as you think it is. They're not that separate. Assigning a variable to another variable does not make an independent copy ever. Sorry, I just ran out of voice here. Assigning two names independently to the same small integer will give them a common memory location, but that's not true for floats or large integers. And again, in number 3, there's still no bad things happening. It's just what happens, right? It's just not bad. Copying simple data like integers, strings, floats, and the like, oh yeah, bad things don't happen, even though they're entangled. They're just, it's not bad yet. But if you start dealing with lists, and I would guess sets and dictionaries, bad things happen. Using deep copy will keep you out of trouble, right? If you want to make sure that the two names are separate. If you want to make sure they're entangled, I guess you don't have to, but if you want to make sure they're detangled, use deep copy. Do not use the little kludge or cheat of row, star column, star value to initialize a two-dimensional matrix. That's bad. That you may, because you end up coupling the rows. I'm sorry, you couple the rows, right? And you probably didn't want to do that. So use something else like the other two methods. How this applies to sets and dictionaries. Yeah, somebody's going to look at that. Well, this notebook took me a weekend actually to build. Seems like a lot of work to come up with these 7. I put a new conclusion in today, so I don't want it to seem like I don't know how to count. So I need to change the word 6 to 7. Here.
I thought maybe you started with 0 or something. Just kidding.
Yeah, I guess they were coupled. So there's other problems with Python. At least, I mean, I love Python. It's fun. It's cheap. It's dirty. It's easy. It's extremely popular. But there's some nasty things about it, like what I showed you today. I don't like white space block delimiting, right? This no need to have brackets to indicate the block structure, to me, is extremely dangerous. It bit me once. I'm sure it'll bit me twice, or bite me twice. So I don't like white space delimiting. Does anyone like that?
I mean, that's all I know from most of my experiences is with Python. So I think that's the indentation is just a thing you just accept with it. I think, a lot of languages have those things that are just like, that's just what we do.
Well, but I don't know of any other structured language that has white space delimit. Like, JavaScript, it's got curly brackets.
Yeah.
I guess most of them have curly brackets, right?
Yeah. Yep. I don't know. I don't know if it was the intention of, is a tab key quicker than two curlies,
By the way, it's funny you should say that. So if you go to the style guide, you're not supposed to do that. Although I do it constantly. I use the tab key. You're supposed to actually use, I think, 4 spaces is the formal.
Yeah, well, I mean, if you're using like PyCharm, which is what I would usually work out of, it works fine. It'll auto indent, or it'll assume, it'll think what you're doing with it. But
yeah, so I don't know. And dynamic typing, which everybody I kind of like, everybody likes, but I mean, would you want to write Python on a machine that, like an X-ray machine? Use Python to control it? I don't know.
I don't know. That doesn't. I'm sorry, you guys, the Python lovers, but there's certain thing. I had a training from he's almost like a technical fellow in the company. There are differences in certain language that you can't just say because this is the latest hottest programming language. For example, all the new college hires, they want to use Java. And that tech fellow, almost like a tech fellow, he explained to me on certain thing that, I don't know, was it timing or something? It just wouldn't work. And he actually gave me some examples. So I really want to caution, like, I like the question you're asking, Dennis, because some of the attendees here are college students, right? At least two people. And I really have to, when you try, if you get the decision making, you really have to look what you're programming. What are you trying to do? What is the software you're trying to achieve? You should do some research on that, because like I said, this person, he has so much experience in this programming world, and he taught me some stuff, and I never forget it. So just think about that. I can't give you an example, but he was using Java versus C++ or something, and he yeah, and this is a real world project. We're not talking about some, hey, let's just automate this,
In the 90s, the government tried to come up with a language called Ada, which is, I'm sure, is still in use, and it it wasn't object oriented, but it was, oh, there's another way, like the very beginning of object orientation. Some languages were object enabled. I forget what the phrase they used is. So they kind of had some aspects of object orientation. But it was designed originally to have it code, program software developers avoid errors, that the language was pretty restrictive and somewhat redundant, and had heavy typing and that kind of thing. And it tried to, be very software safety conscious and avoid errors. And I would say Python is kind of the opposite, where it's quick, it's easy, but you kind of have to know what you're doing. If most of us, it doesn't matter. Certainly, if you're using it to automate cybersecurity issues, I don't think it's terribly dangerous. But like I said, I don't know if I'd want to write an X-ray machine and the software for it in Python.
Yeah, I would use Python for quick, like you said, Dennis, for automation or quick whatever scripting.
But you can do
really
very
think
complex things, complex data analysis with Python. It's a very powerful language, and the libraries make it extremely powerful. If there's something you want to do with the software and the computer, there's probably a Python library to do it. So, all right, that's the end of my talk. Like I said, the link to this page is in the Python channel of our Slack environment, and you can go grab this page. I put my name and email in it, so you can contact me. And I did leverage a lot of other people's work, articles in Medium and other things, in trying to figure all this out. But hopefully I gave them enough citation at the top and that kind of thing. So that's it. That's my talk. Hope you enjoyed it. I had fun doing it. And if anyone wants to do the talk, I encourage you to do that for the group.